All right, so we're going to be working on how to balance chemical equations. And remember, the reason we're balancing chemical equations is we need to show an equation that reflects what really happens in the real world. And that is that, again, atoms cannot be created or destroyed after a reaction. And so we need to make sure that we have the same number of atoms in the reactant side as we do in the product side to show that. So let's start off with the chemical equation of magnesium and hydrochloric acid becoming magnesium chloride with hydrogen. All right, so the first thing that I wanted you to do on that practicing the balancing act is for that sheet you need to both draw all of the atoms in the reactant side and the product side, and then also balance the equation using your counting system that you have on the reactants and product side. So on the bottom here we'll do our counting. We have magnesiums on the reactant side. Let's draw that line. We have hydrogens and we have chlorines. Okay, and of course on this side we're also going to have magnesiums, hydrogens, and chlorines. And remember, our goal is to have them be balanced so that the reactants, the number of atoms on the reactant side is equal to the number of atoms on the product side. And now we're going to actually draw what we have so far. So I'm going to have magnesium be my black circle. And we're going to create a line. Again, here are my reactants. And here are my products. So just to help me not change pens so much, it looks like right over here I have one magnesium, so I'm going to draw one single magnesium. On this side, however, it looks like I have a magnesium, but that magnesium is combined with two chlorines, okay? So whenever they're written together without a plus sign in between, that means that they're all bonded together. And I'm going to make chlorine be orange, okay? So these are going to be my chlorines. So in that case, I have two of them, so I need to make sure that I bond them. That magnesium with two chlorines, all right? On this side here, I also have a chlorine, and looks like that chlorine is attached to a hydrogen. So let's change my ink color to green, and green is going to be my hydrogen. All right, so for that reason, I have the chlorine and the hydrogen becoming together. That's an orange and a green circle. The magnesium is by itself, and here I have a magnesium with two chlorines, and I have a pair of hydrogens. So remember, if you have that subscript, that tells you how many of those atoms you have, and so we have two hydrogens, they're paired together. So let's do our counting system and see how much we have of everything, and I'll move to the black pen again. So it looks like I have one magnesium here, and I have one magnesium here. They are both balanced, so you have the same number in the reactant side as in the product side. So let's take a look now at the chlorines. The chlorines, it looks like I have one chlorine here, and I have two chlorines here. So these definitely are not balanced. And hydrogen, I have one hydrogen here, and I have two chlorines here. So the hydrogens aren't balanced either. And whenever you have different chemicals that aren't balanced, I always sort of suggest don't do the carbons, the hydrogens, and the oxygens. Don't do CHO, I'll call it CHO, until you've done everything else. So we've got the magnesiums balanced, and I want to avoid that hydrogen to the end. It just makes life easier. So let's try the chlorines, okay? So here I only have one chlorine on this side. I need to get two. So remember, you can only add more of the same thing. And so for that reason, I'm going to add one more. Let's get that going here. I'm going to add one more hydrochloric acid. Draw a line. Get an ink color. There we go. Okay. So now in terms of my numbers, let's change the numbers. Remember, I could only add one more of the same thing, that being a hydrochloric acid. So now I have 2 hydrogens and I have 2 chlorines. Do we have a balanced equation? And it looks, hey, it does. Often the hydrogens kind of work on its own. So now let's do our adding of how much we have of each item. So move back to the black pen. There we go. So we have 1 magnesium. Because we have a 1, we don't need to put a number here. We have 2 hydrogen chlorides. Okay, excuse me. We have 2 hydrochloric acids. So one is here, the other one is here. We have just 1 magnesium chloride to have it be balanced, and we have 1 hydrogen diatomic atom, so H2. Okay, and we have a balanced chemical equation. All is good. So as I said, for the first sheet, the balancing act, I want to see these numbers here, and I want to see the images as well, just as a way for you to actually see how these really look like in real life. So now let's try something that's a little bit more mathematical, where you just sort of play with numbers. And I'm going to move on to the next slide. There we go. And I'll work through one of the equations that you have on the second sheet where I'd like you to practice them. And I'll do number 2. Okay, so we have potassium chlorate with KCl, potassium chloride, and oxygen. Okay. So as I said, do non-CHO CHO first, okay? So that means ignore the carbons, the hydrogens, and oxygens. And to looking at this here, it looks like we have potassiums, and we can just kind of toggle back and forth. So it looks like for our potassiums, we have a 1-to-1 ratio. Chlorines, we have a 1-to-1 ratio. All is good, but we have now these oxygens. They do not seem to be on a 1-to-1 ratio, and this is where you can start playing with numbers of coefficients. And oxygen is one of these unusual ones because often any sort of diatomic atom that's by itself is sometimes hard to get them to be balanced. So I'm giving you one of the more difficult ones, and I have 2 oxygens here. So my oxygens, we have 2 oxygens, and here I have 3 oxygens. So how can you make it balance out? So here's what I do, is you take this number and you multiply it by this number, okay? So that you have 6. All right, so we have the common number of oxygens could be 6. So if I put a 3 here, oops, and I put a 2 here, that balances out my oxygens because I simply multiply them or switch them, okay? And now I need to make sure that my potassiums are equal. So I have 2 potassiums here. I need to get 2 here, so I'm going to place the number 2. I have 2 chlorines here because remember when we have what we call the coefficient or the big ass numbers that distributes all along here. I have 2 chlorines here. I have 2 chlorines here, so that works out. And I have 6 oxygens here, and I have 6 oxygens here. So it's a quick way of doing it where you literally just sort of swap the numbers. Okay, let's try one more. That is an oxygen, so you see what that looks like, okay? Or actually, let's see. Yeah, we'll do an oxygen. So I have phosphorus with O2 becoming diphosphorus pentaoxide. All right, again, we're going to work with numbers that are not carbon, hydrogen, or oxygen, not CHO. So in this case, I have 2 phosphorus here, so that I can simply put a 2 here. Remember, I can only give those big numbers, and that takes care of my phosphoruses. Here, however, I have 5 oxygens. Here I only have 2, okay? And again, we can just sort of swap those numbers. So if I have 5 here and a 2 here, the common denominator in those would be probably 10. So in order to get 10, I can only put that big number here. So now I have 10 oxygens here, 10 oxygens here. But with that said, I now have 4 phosphoruses. So for that reason, this is no longer a 2, but I need to make this a 4. And the chemical equation is balanced, all right? So just to go back of what that looks like, if I have phosphorus being dark circles, I have on my reactant sides 4 phosphoruses that are individual, okay? And on this side, I have 2 phosphorus, but I have 2 sets of them. I'm going to just do this so I don't have to change color so often. And let's get a nice red. All right, here I have 5 oxygens, and let me just give the code here. 5 pairs of oxygen, because they're diatomic. And remember, I can only give more of the same. So I just can't give one individual one. And I need to add 5 oxygens combined over here. All right, and there we have it. Okay, so that's what it looks like, and if you do your counting, you'll see there are 4 phosphoruses here, 4 phosphoruses here. There are 10 oxygens here, and there are 10 oxygens here. Our equations are balanced. That's it.